Hello. In this tutorial, we'll walk through the complete process of using the LUSAS Tank module to model the roof steel frame of a metallic storage tank, and then perform a steel frame design check, step by step. The overall workflow for this example is divided into two main stages. The first is analysis modeling. We'll define the tank definition, generate the 3D shell model, and set up the design standards required for the steel frame design check. The second stage is analysis and results review. After running the analysis, we'll define the steel frame design attributes, check the UtilMax, that is the maximum utilization ratio results, and then export both the tabular results and the detailed calculation report. We'll now define the tank definition. From the top menu, go to Tank Definition. This is where you enter the basic data needed to build a 3D shell model of a metallic tank using the tank module. When the dialog opens, set the material type to metallic. In this example, all geometry and conditions for the tank will be configured using the values defined in this tank definition dialog. To generate a 3D shell structural analysis model, select the 3D shell structural option under the target models to build section at the top of the dialog. Now move to the base slab tab. This is where you define the geometry of the base slab. The key inputs are the inner radius, outer radius, and thickness. These values directly determine the overall base dimensions of the analysis model. Next, move to the wall tab. This is where you enter information about the tank wall. There are three main items to define here. The first is the inner radius of the tank wall. The second is the height and thickness of each wall segment. The third is the position of wall stiffeners. If the wall is divided into multiple segments with different thicknesses rather than a single uniform member, you define the height and thickness of each segment here separately. Now move to the Roof Lateral tab. You define the overall roof geometry and lateral ring information. The key inputs include the spherical radius of the roof, the distance from the center to each lateral ring, and the length of the compression ring. This step determines the curvature of the roof and the positioning of the rings. In other words, how shallow or steep the roof is, and where the steel frame members are placed. Next, move to the Roof Polar tab. This is where you define the configuration of the main steel members running from the center of the roof outward. Now the Beam Section tab, and this one is important because this is where you define the cross-section profiles for the roof steelwork. In this example, we'll be using IPE sections from the EU sections library. We'll assign the required section to each roof member in turn. Move to the Material tab. Here you enter the material property data. We'll use the default material data for this example. Now let's look at the Support 2D and Load tabs. The Support 2D tab is not used for 3D analysis models, so leave it at its default values. In the Load tab, you define the static loads required for the analysis. This includes structural dead loading and structural variable loading. Loads are applied separately to the roof wall and base slab depending on their type. In this tutorial, we'll generate the base model using the load information defined in the tank definition. Finally, move to the Support 3D tab. This is where you define the actual support conditions for the 3D model. In particular, selecting detailed foundation under the support type allows you to model more specific support conditions, including pile foundations. Once you've finished defining everything for the model, click OK to close the dialog. The tank definition data you've set up is saved under the Tree View Utilities tab. Now, let's generate the model. From the top menu, go to Tank, Create 3D Shell Model. When the dialog opens, select the tank definition data you defined earlier and specify the model file name. To generate the full model, uncheck the half symmetric model option. Once you've configured the settings, click OK and the 3D shell analysis model will be generated automatically based on the tank definition values you entered. Once the model is generated, the full tank geometry will be displayed on screen. Check that the roof has been created with the intended curvature, that the wall and base slab are properly connected, and that the steel members on the roof are arranged as expected. Next, go to the Tree View, Attributes tab, to verify the geometric attributes assigned to the roof steel members. Now, we'll define the steel design standard. From the top menu, go to Design, Steel Frame Design. Set the country to Europe and select EN1993-1-1 as the design standard, under the FY and FU chosen. From Option, select Product Standard. This setting automatically looks up the yield strength FY and ultimate strength FU based on the actual thickness of the section in accordance with the material product standard. By contrast, selecting Table 3.1 applies the nominal values from Table 3.1 of EN1993-1-1 directly using the appropriate thickness range. Now save the model and run the analysis. Once the analysis is complete, the next step is to assign the steel frame design attributes and review the design results. Now, we'll define the design check attributes to be applied to each steel member. From the top menu, go to Attributes, Design, Steel Frame Design. In the General tab, define the section Fabrication Method and Material Standard. Set the section fabrication to hot rolled section and the steel product standard to EN 10025-3. Set the steel grade to S355N/NL. This value determines the yield strength basis and also affects the buckling curve selection. The steel grade used in the actual model must match this setting. Set the ratio of net area to gross area. This is the ratio of the net cross-sectional area to the gross cross-sectional area, and enter 0.9. Next is the Compression tab. Here you define the effective buckling lengths for compression member checks. For major axis unbrace length, from, minor axis unbrace length from, and torsional unbrace length from, all select line. Leave the remaining settings at their default values. In the Bending tab, define the lateral torsional buckling conditions. Flange restraint refers to whether the compression flange is laterally restrained. Set this to no restraint and leave the remaining inputs at their default values. In the Shear tab, define the conditions related to the shear check. Leave all settings at their default values. In the Advanced tab, you can manually enter the equivalent uniform moment factors. Please refer to the manual for a detailed explanation of these input values. Now, we'll apply the Design Check attributes. In the Tree View, Attributes tab, select all of the rafter beams, bracing, and lateral beams. Apply the steel frame design attribute defined earlier to the selected members. Now we'll review the design check results. First, set the target load case for the design check as set active. Then display the contours. In the results settings, set the entity to steel frame. EN 1993-1-1 and the component to UtilMax. UtilMax represents the highest utilization ratio across all design check items, including tension, compression, bending, shear, buckling, lateral torsional buckling, and combined axial force and bending. If UtilMax exceeds 1.0, the member does not satisfy the design standard. The steel design check results for self-weight show a maximum UtilMax of 0.195, which is below 1.0. Final design adequacy should be verified against the design envelope covering all ULS load combinations. Now, let's look at the detailed results in tabular form. From the top menu, go to Design, Steel Frame Design Results. This outputs the design check results for the entire model or selected members in a table format, allowing you to review the utilization ratios for tension, compression, bending, shear, buckling, and more for each member at a glance. Running the menu creates a steel frame design results entry under the Utilities tab. Right-click on it and select Show Results to display the results for each member in a table. From the Results window, select a specific member and click the Detailed Calculations button to jump directly to the detailed calculation report for that member. Finally, we'll export the detailed design report. Select the target members for the report, then from the top menu, go to Design, Steel Frame Design Report, Selected Lines. This outputs results based on the most critical location within the selected line. Choosing specified location allows you to manually specify an element number and position to output results at that exact point. This function shows the detailed EN1993-1-1 clause by clause design calculations for the selected member, including the applied section forces, section classification, the calculation process for each resistance value, and the relevant clause references and formulas, all presented in order. Using the Add to Report button within the report, you can also add these calculations to the overall model report. That brings us to the end of this tutorial. We've walked through the complete process of using the LUSAS Tank module to model the roof steel frame of an LNG storage tank and perform a steel frame design check to Eurocode standards.